So my name is Geoff Wilmington. I'm a technical product manager with the Networking Security Business Unit. I focus on the security aspects of the NSX products, so distributed firewall, edge firewall, our guest introspection services, service insertion, and so forth for our Layer 7 partners and so forth. A little bit today is just a little bit of an intro to NSX. How many folks I know some folks are familiar with NSX. How many have actually used it on a in a workload environment? Know a little bit about it? Maybe don't know a little bit about it. Okay, cool. I want to make sure that I get through the introduction, so we kind of level set kind of the expectation of what we're going through and so forth. And we're going to talk about NSX Data Center and NSX Cloud. Is my mic? Is everything okay? You guys look a little okay. Cool. Okay. Awesome. So NSX Data Center is functionally what we've been doing is if you think about virtualization and what we've done with like the ESXi hypervisor, right? We basically said bring your commodity hardware, your HP, your Dell, your whatever kind of hardware, and basically run our software on top of that, and basically virtualize those physical infrastructure types of services. And so from an NSX perspective, we've taken that same concept and we've said that physical infrastructure to us, we're agnostic to that infrastructure, right? There are certain things that we need from that infrastructure to run, things like MTU, highly resilient, and basically let's move some packets, right? That type of equipment, that we have that physical infrastructure, and we're going to take those data services that we would typically use, or that we typically buy products for, so routers and switching and so forth, things that have been generally distributed around our data centers, and bring them closer to our applications. So we do that by providing the NSX platform inside the virtualization layer, or inside the hypervisor of the ESXi host. So we're taking things like routing, switching, firewalling, and things like load balancing, and we're putting them directly into the ESXi hypervisor. And as we do that, we're taking these concepts and moving these services that we would typically have to either provide routing for or send traffic to an external firewall, and we're bringing them closer to the actual applications themselves, so that we can take those services and provide them right to the application, regardless of workload type. So we have virtual machines. NSX supports virtual machines, supports bare metal systems, supports container-based workloads, and then we layer in the NSX Cloud portion of this. And NSX Cloud, what that has done is it's a piece that interacts with the NSX Manager on premises, and helps provide the same networking and security services for the workloads on premises to our cloud providers. So that would be VMware cloud providers or native public clouds like Azure or AWS. So what we are functionally doing here is we're saying, much like Tom was saying, we want to provide that ubiquitous and consistent networking and security enforcement, regardless of where that workload lives, whether it's on premises or off premises. Does that make sense? Okay. So a little bit into what we're doing from NSX in terms of security. So from a use case perspective, these are the types of use cases that we typically see with our customers in terms of how we provide security to those for those different use cases. Our first one being around micro-segmentation, and that's our ability to provide security services as close to the application as possible and create isolated zones around those applications so that we can control traffic. Oops, hit the button too fast. We can control traffic between the systems. Secure end user desktop and computing is a very similar concept where VDI desktop infrastructures have lots of desktop pools and so forth, and our ability to control traffic between those desktop pools. Lastly, being around DMZ and software. So our ability to say that from a security perspective, lots of organizations have built air-gapped DMZs. They have specific hardware and equipment that does that specific function where they have sandwich firewalls between those systems. I don't know why this thing keeps moving. Maybe I keep hitting the button. But from a DMZ perspective, if we put a firewall at all of our virtual workloads, functionally we're creating DMZs within software, right? Because we're creating that firewall at that virtual machine level. And if we can control traffic from one virtual machine to another, DMZs are actually be easy for us to actually create security policies to actually make that happen. And I'll go into that in just a little bit. So very similar to what Tom was talking about, and I'll kind of speed through this since he covered a lot of this, but basically what we've done from a security perspective, or what we've seen with customers is that getting into the environment is generally pretty difficult, right? We put large firewall services at the perimeter, but if someone were to get through those systems, either through some legitimate method or through some illegitimate method, then their ability to move freely around the data center becomes very, very easy. And that's generally because we don't have security services between our systems. And if you think about this from a north-south or an east-west perspective, most of the traffic we've talked about in the past has been like north-south is 80% of our traffic and 20% is more east-west. But actually, if you think about it, as our applications have grown and have expanded inside the data center, that the majority of our traffic now is actually east-west. And we don't provide security services for a lot of applications, or it's operationally infeasible, because if you have to put physical firewalls here, then I have to do lots of going back and forth and trying to figure these things out as applications need to talk to each other. So what we do is, what if we could take that zero trust model that Forrester was talking about from, assuming that everything is a threat and then acting accordingly, and take all of our virtual machines and place firewalls at the VNIC of every one of those virtual machines. What does that mean to us? That means, thanks, Geoff, you just gave me 1,000 firewalls for every one of my virtual machines in my environment. I appreciate you putting a firewall at every one of my virtual machines. But what that really means is that now we have some very, very fine-grained ability to control security between these virtual machines. Right? We can say that these virtual machines, or one virtual machine can talk to another, but not necessarily another. And that we can individualize all of the security. So what we've seen with a lot of our customers is that when they start down the NSX path for security, it's not they want to secure the entire data center as they start out. It's generally they have a specific use case, something like, say, PCI compliance, right, where they have some workloads that they want to place a security posture around that's different than other environments. Having a firewall at every one of my VMs and having the ability to provide individual security policies for each one of those different systems, or logically group constructs, so saying these are my PCI systems, maybe I want a different kind of security posture, and creating a security policy that's enforced at every one of those VMs consistently, regardless of location. Go ahead.
Pardon me.
Sure.
But most of these VMs probably have host-based firewalls already.
Sure. So
what's your value compared to that? Why couldn't I just configure my host-based firewall?
So host-based firewall, let's take a Windows example, right? So configuring a Windows-based firewall means that I would need to use Active Directory group policy to enforce those things, right? How long does it take to push a group policy down to a system? It could take
less than 10 minutes.
It could take less than 10 minutes. I can do it in less than a second.
But it's a one-time click either way.
Right. So what I'm saying is that what we're doing that's different than, say, a host-based firewall is that our firewall is at the VNIC of every one of our virtual machines. So let me explain kind of what that means. Take a physical server, for example, right? We have a physical server, we take a cable and we patch it into a switch, okay? What if I put a firewall right in the middle of that cable? That's what we're doing. And not only that, we're saying that so I can control traffic in and out of that system that's not host-based. It's within the kernel of the ESXi hypervisor, and it's not disableable.
So is it part of the distributed vSwitch, or is it on the VNIC on the?
It's between the distributed switch and the VNIC. So it's right in the middle of that. So I'll kind of show a little bit. I'll show a slide that kind of talks.
So do you take any kind of hit, or is there a CPU cycle loss for this? Because again, whenever you put a firewall in, your traffic generates.
Absolutely, right. So there's always going to be some hit. What we've seen at scale is 3 to 5% worth of CPU overhead. Okay, that's so. And I'll explain this a little bit further.
That could be a lot if you have a lot of VMs. That could get big quick.
Yeah, but let me kind of break that out for you in just a second here. So let me hit this whiteboard real quick. So if I have a vSphere host with VMs on it, And each one of these VMs has a firewall before it goes outside to the logical network. Think about this. As I'm saying that we're putting the firewalling capabilities inside the ESXi host, okay? How many hosts do certain customers have? Maybe tens, maybe hundreds, maybe thousands, right? This, putting that firewalling service in the host itself, scales horizontally. So technically, as you add more hosts to your environment, this firewall gets bigger. And we take things like consolidation ratios, 20 to 1, 30 to 1, right? If I had 1,000 virtual machines and I needed to provide security between all 1,000 of those virtual machines, if I did it with a physical firewall, I would need a very large firewall to accomplish that, right? From the host perspective, if I'm running the security software in my kernel, I get kernel speeds, or near line rate speeds. So if you had two 10 gig NICs coming out the back of this, I could push around 19 gigabits a second worth of firewall throughput. Okay? I can push that much capability at the 3 to 5% overhead of what I'm talking about. But I don't have to always push that amount, right? Because think about it. My virtual hosts have a consolidation ratio of, say, 20 to 1 or 30 to 1. If you use a physical firewall, I need a firewall that supports all 1,000 of my virtual machines, right? If I use the NSX firewall that's in the kernel itself, I only need to provide firewalling services for the consolidation ratio that sits on that host itself, because all of that firewalling takes place in the host. Does that make sense? So as I scale and I add new workloads, I add more firewalling capability, I add more routing capability, and I add more switching capability. Back to your question on the host-based side of things. Since we're running in kernel, even if you were to disable the firewall, it fails closed. Okay, so you would have to compromise the hypervisor to be able to do that. If you were an attacker, what's generally the first thing that you do when you attack a system? I shut the AV off. I shut the host-based firewall off, right? I shut those things down. Those are things that are easily compromisable on a system basis. If I have a firewall that cannot be shut down from the guest because it's running in my host, that is a much better, and it reacts in a sub-millisecond, sub-second type of response time in terms of being able to apply a security policy.
That's a great point. Let me just counter with this question. Most traffic these days is over port 443.
Okay.
HTTPS.
I saw the tweets, and I know somebody hates HTTPS, I think.
Oh, I'm sorry. Your firewall's not going to be able to have any insight into that unless you intercept it and decrypt it. Is there any thought about that?
Sure.
On your firewall side?
Sure. So from our firewall side, as I'm going to kind of move over here, we do have some layer 7 capabilities within our firewall. Okay. So we have roughly around 70 or so application IDs for taking a look at traffic. Now, we look at the packet. We're not actually, so you talk about HTTPS, right? So we are not an SSL proxy. So we're not going to decrypt. We're not going to depacket and inspect and go from there. Because that's a very CPU intensive process, we have partners that do those things, so Palo Altos and checkpoints. The nice thing about NSX from that perspective is if you want to send for deeper packet inspection that's past our firewall level, you can redirect those services to a third-party service, a third-party SVM that can actually do those things. So if you wanted to look at HTTPS traffic and you wanted to do actual inspection of what's inside that, there are partners that we partner with, Checkpoint and Firewall, and Fortinet and Palo Alto, that have been doing this for a lot longer than we have and have a more robust threat prevention, right? So we don't have IPS, we don't do deep packet in that regard. So what we can do though is from our firewall, we can say if it's coming across HTTPS, I can take a look at the sub data within the packet header and say, what version of TLS is it actually coming across? So I can actually still control from a layer 7 perspective. I can say, you can run HTTPS, but it's got to be TLS version 1.2, right? So we're not going to allow 1.1 to run in our environment or anything along those lines. So we can get that granular from that perspective. I know kind of where you're going. That's where we have our third-party integrations.
Well,
for that.
Chris just challenged me on Twitter, and he said he would challenge the idea that most traffic east-west is 443. And you're probably right. It's more 389,
It's pretty much-
1433.
There is gonna be some
3306,
Excel, but most of it's
1433,
gonna be
SQL traffic,
That-
those kinds of things.
That's right. But
Sure.
I mean, yeah, I would agree with you on that, but it still begs the question: where's the real value here? Is it just performance based?
Let me tag this to a question that I'll post
go
to
ahead,
Geoff.
take it
Is,
over.
so you're saying, hey, I can stand up a group policy and establish, a policy in each of these machines, and then write some scripts and push out to each of my Linux machines.
Sure.
I bring up a new domain controller, new IP address. Now I have to go do a whole bunch of busy work to allow east-west traffic for each of those. Versus he can establish a policy and says, I allow this traffic because I trust it by establishment, and it pushes to everything instantly.
But that's what group
Where this
policy
win-
does
where this-
for
where-
Windows.
Where this wins is in the DevOps model, where you're out of bounds, where a security team can still be a security team and make sure that the firewall rules are going to be the
get a-
same
you get a
across everything,
compliance
and
check.
just say, here, you want to
Yeah.
deploy a VM? Do whatever you want, but we control the firewall.
So-
And I
Well,
like
and it's more than just the compliance check. You win at the DevOps layer because
Yeah.
now the admin can't disable it.
Yep.
But you also win at the compromised host level because now the attacker can't disable it.
And you can then quarantine the host independent of the individual machine because it's being controlled by an outside controller.
Yeah, it's out of bounds.
Yes.
Yes, and so
and there's a performance is better than host based.
yeah, so if you've seen some things like agentless offload for agentless antivirus, right? Generally, the performance is much better than running full agents with inside the actual system.
Yeah.
If you think about it in terms of like Windows-based firewalling or IP tables or whatever, you have to know a lot of information to be able to write those rules. And every time that you need to either add another application or that application changes or something, I've got to go back to that policy. I've got to redo it. And it's a lot of operational overhead to run it in that regard. What we can do is we take the inventory information from things like vCenter and so forth, and we can write our security policies based on objects from, like, say, vCenter, right? So I can say that VM1 is my web app, and VM2 is my database or my application server, and anytime I decide to spin up another web server, it would immediately be pushed into the same security group, and then the security would immediately take place. If you were to do that via group policy, you would have to build the machine, then I would have to add it to the group policy. I have to do a lot of extra overhead to kind of do that, especially for something that could be easily compromised by just shutting down the firewall. So from our perspective, the VM admins or any person that's actually using the server itself could not disable the firewall. They would have to be.
That's a great point. I would suggest the other thing you could say is that your product, your firewall product, probably has central logging. It's very difficult to do central logging with Windows Firewall.
Yeah.
And I don't even know where I would start with it on a host-based firewall on Linux.
Yeah.
Or even event viewer generating 5 million transactions per millisecond.
Yeah, and I'll show some of that, and I could show kind of what we're doing from a logging perspective. Oh, Qasim,
I think one of the previous points that we were talking about of the east-west traffic. So if you think about NSX layer 7 firewalling, it's actually tailor-made for layer 7 east-west. So the app IDs that we give is really Active Directory, DNS traffic, SQL traffic, these kind of app IDs. We're not really looking at URLs or Facebook chat or something like that.
Yeah, those are more.
That's more north.
Those more north-south types of scenarios, right? So from an NSX's perspective, the value add, if you will, is our ability to help secure that lateral movement. So from VM blue to VM green, most environments have unrestricted or unnecessary traffic that could be either be instantiated, could come up between these systems. One system could actually talk to another. There's 65,000 open TCP ports. So any port or protocol could be used. And not only that, but there's no real context awareness really of what that application actually is, not without some kind of third-party type of service. But with NSX, go ahead.
Sorry, Geoff.
Yeah.
Just a question. I didn't get what is done by the NSX firewall and what is done by your ecosystem partner.
Sure. So from our firewall perspective, I'm getting ready to get to that in just a second. So from our firewall perspective, we put the firewall at the VNIC of every one of our virtual machines, and that is a stateful layer 2 through layer 4 plus a little bit of layer 7 firewalling capability. Okay, so this isn't ACLs or anything like that. This is a stateful. We have a connection tracker that's actually within inside the actual ESXi hypervisor. So we are keeping track of those conversations and so forth, so that when the virtual machines establish a communication, there's no need to write bidirectional rule sets for those systems. It is a stateful system. So per VNIC, stateful services. If you need to go outside of the services, like Kausen was saying, if you need to go outside of the IDs that we have, or you want something like an SSL proxy where you want to dig into 443, that's where you would do some kind of we would do service assertion. So what that means is we can have the ability to write our rules and we can redirect traffic to a third-party system.
Because the NSX solution is based on the group-based policy and the contracts, right? It's like OpenStack.
Yeah, so if I say this machine talks to this machine, and maybe it talks over a couple of different services, right? But I want to actually take a look inside HTTPS and I want to do deep packet inspection. I don't have to send all my traffic like you would have to send in a physical world. I would have to send everything over to the DPI engine and everything would be sent. If I knew that I didn't need to look inside HTTPS or anything else, but I wanted to look inside HTTPS, I could send just HTTPS traffic to those DPI third partners and have them actually do the detection. That way, what we say is let the NSX firewall, the distributed firewall, do the bulk of the east-west firewalling as much as possible for these types of services. Right? So let it do the bulk of that. If you need to send it somewhere else, send specific traffic. And we have that ability to redirect specific types of traffic to the third-party system to do that.
That can be physical or virtual.
Mm-hmm. Yes. So as you come in, if you had traffic coming from a physical environment, if this was a physical server, right? Okay. And it was coming in, I could send any traffic that's coming from this destination to the third-party system if I wanted to do that. Okay? So we get down to that fine-grained security, and like Tom was saying, it's about shrinking that attack surface, right? So if blue needs to talk to green, and we only know that it needs to talk over a specific port and protocol, and we only know that blue needs to instantiate the conversation to green, web to app, right? App can respond, but app should never necessarily instantiate a communication back to the web server or a database or something like that. So we can control that east-west traffic by specifically writing a policy that says these two systems talk over these ports and that's it. That means all of the other unused ports that are normally open in this type of scenario are now closed, and the only way for someone to compromise that system, it's not a silver bullet, but we bring down that attack surface, right? So we limit the options of someone being able to traverse laterally in the environment. The other thing is
I've got a question.
Oh, go ahead.
So I work with a lot of different organizations. I'm almost always saying segment your data, right?
Sure.
Segment your network, segment your systems. The pushback I always get is, well, we don't necessarily understand our workloads. We don't necessarily understand what the traffic is.
Yep.
If we do it, it's going to take too long to implement. If we do it, something might break. And that's just segmenting, let's say, a DMZ or a manufacturing plant,
yep,
let alone doing micro-segmentation. What tools, you keep saying you know this, and if it was just two VMs, great. What tools do you guys offer on an enterprise side so that I can counter that? Well, okay, I know you don't know, but here, let me help you figure that out.
Sure. And so I'm going to get to that part and the operationalizing piece. We're going to talk about writing security policy and the tools that are associated with it.
Rock on.
Make sense? So this is what to speed up a little bit, this is what we're basically able to do, right? We're able to take the VM concepts of all the virtual types of workloads that exist in your environment, create logical constructs around those systems. We can create security groupings around that application itself. And then now every VM can be its own perimeter. So we can start saying that this system can talk to this system and this system can talk to this system, but this system cannot talk to any other applications in our environment. So going back to kind of the DMZ use case or something similar, you could technically have a web application that sits in your data center sitting right next to your HR database, but you have not allowed those systems to talk to each other. So there's no way for someone to laterally traverse to that other application because you have a different security posture for your HR application that is different than, say, your web-facing types of systems.
And one thing that I would often jump up in some of these things, whether you're doing some type of firewalling, is since it's at the VNIC level, it doesn't matter what your MAC address or your IP address
Absolutely.
is because it follows the machine, right?
Yeah, absolutely. So the magic that we do, when I say that we do things at layer 2, right? So what we do is we still at the data plane layer still translate those systems to IP addresses, right? That we still translate those things to MAC addresses and so forth. But we do all that, we do all that on our side. So when you write your rule set, you just say web to app or virtual machine name to virtual machine name, and then we do the translation at the data plane.
So, wow.
So that means,
Use like an FQDN.
what's that?
You couldn't just put in an
It's more like a GUID at that point.
Okay.
GUID 1 can talk to GUID 2.
So when I firewall my systems, my VMs, I think about FQDNs mostly.
FQDNs, IP
And I-
addresses.
We write our apps to
Yep.
FQDNs,
Yep.
but
I can spoof that. This
you
is
could
harder.
if you attack the DNS server.
So we're working on things like that. So FQDN-based firewalling, we're going to be doing some things like that next
Okay.
year, where we're going to be able to have those things, especially for things like URL filtering and so forth. Those kinds of things are going to be coming. But like I said, this makes it network topology agnostic, meaning that it doesn't matter whether or not these systems are on a flat layer 2 network or multi-layer 3 networks. It doesn't matter to us. We can still provide the same kind of firewalling capability, even if you have one large layer 2 segment. So there is a customer that I know of that puts all of their virtual machines on one giant network. How do you do security in the physical world to that? It's very, very difficult, right? So if I have all my virtual machines sitting on one network, I could use the NSX firewall to still control traffic between those systems regardless of what the topology of the underlying physical network actually looks like. Okay? Talk a little bit about how we do some of these things. So from a context perspective, layer 2 through layer 4 for 5 tuple, I mean, that's pretty straightforward. Layer 7 application ID, network context being things like logical switches. So the nice thing is that from NSX's perspective, you can select different types of objects to create your security policy. You don't have to use VMs. You can still use IP addresses if you want to use those. So for things from the physical world that are accessing your applications, you can still control traffic using an IP address as necessary. You could have logical networking from an NSX perspective. So if you're building logical networks, logical layer 2 networks in NSX, that right on top of your underlay, the logical switch, you can use the logical switch construct that says all my virtual machines that live on that logical switch, I can control traffic for those systems as well. Workload context being things like security tagging, operating system VM names, and security posture. So one of the use cases we had for some of our customers is around operating system type. So customers that were leveraging or using, I used the word leverage wrong, Windows Server 2003 systems. They had a lot of Windows Server 2003 systems. They were trying to figure out which those systems were. You can actually create a security group that says if the OS name equals Windows Server 2003, I want to group all these constructs immediately. So I can immediately group those constructs right into one security group right away and immediately start looking at how I want to secure those systems. Security tagging being our ability to basically tag a system and say that maybe it's part of the application tier, maybe it's part of the production, it's part of the production application and so forth. As you build systems, the nice thing about this is you can create a security group. And if you tag it with a specific security tag, it can be placed automatically into that security group. I'm going to talk a little bit about how the security group concepts work in just a few minutes. The other thing is, I kind of glanced over this a little bit, is around user context and our ability to do identity-based firewalling. So that is our ability to use a context engine that we have within the hypervisor itself that actually does a lookup against an Active Directory SID. And what it can do is it can place that user and say these users have access to this application. And the way you write your security rule is you say this Active Directory group, regardless of where they live, is accessing this application, and only those users can access those.
Like in a Kerberos ticket, you could look at the SID.
Yeah. So when we do a TCP connection between it has to be TCP based right now. We're doing things like ICMP and UDP and so forth.
Okay.
But if a user instantiates a TCP connection to another server, the identity firewall immediately checks the user against the actual Active Directory SID group that they belong to.
Right.
And if they don't belong in that group, it won't allow communication. That make sense? User session-based being things around RDSH. So folks familiar with RDSH, remote desktop session host,
Yeah.
right? So, so I said that our firewall translates things to an IP address. RDSH-based systems, if you write firewall rules for RDSH-based system, what's wrong with that?
FQDN based. It's got a broker.
Well, it's broken because there could be 50 users logged into that system, all doing different things, right? So what we've done from RDSH's perspective is we've used that user context like I was discussing before, and as users log in to the actual RDSH system, we can write granular-based policies based on each one of the different user groups. So 50 people from 50 different groups could be logged into one RDSH host, and I can control all 50 of those users and where they go.
But TCP only.
TCP only right now.
Okay.
Yep. So security groups are the what you want to protect, right? So this is our ability to basically group the logical groupings between the systems, right? So dynamic inclusion, static inclusion, and static exclusion. Let's go back to 6th grade math. Please excuse my dear Aunt Sally. Everybody remember that? So the way that this works is dynamic inclusion plus static inclusion minus static exclusion equals what groups mean. Okay? Do the parentheses first, go from there, and that's how your groups get built. The nice thing about this is that we can use all the different types of membership criteria. So we have computer names, entity, VM names, and so forth that can actually be used to create these security groups. So they don't have to be IP addresses. They can be logical constructs from, say, something like vCenter. And then the security policy is the how, and that's the how you want to protect these systems, right? So do I want to create, create a policy and then apply it as many times as I want to create that. So things like anti-malware, vulnerability management for things like guest introspection. So if I want to redirect traffic for antivirus systems and so forth, I would use guest introspection. For network introspection, that's where I would do things like IDS, IPS services, or third-party layer 7 deep packet inspection is how I would do those things, okay? Talk a little bit about operationalizing, and I'm going to get to the demo. So zero trust, we're going to kind of go through this, right? This is, real quick, basically the starting assumption, we treat everything like a threat, and then we act accordingly. The design principles around isolation and segmentation, basically saying that we're going to isolate the applications and then segment them, right? So we can either do isolation through network virtualization by creating logical networks with NSX and isolate those systems from one another. And then we can do segmentation is by saying that virtual machines that sit on those logical networks can't talk to each other or can talk to each other over specific types of ports and protocol. The basic being around least privilege, right? Again, network least privilege is saying that this system can only talk to this system over this port and protocol or this context. And last, oh, go ahead.
In reality, outside of greenfield opportunities, do you see people actually adopting a zero trust model, or are they going it's zero trust except we trust everything and then we build policies around it, but even then we still can't pull that trigger?
Yeah, so that's where things like the tools have come into place to kind of help,
which are great tools
to help get those things kind of moving, right, and get those projects moving, because everybody knows that every application owner has documented fully every one of their applications, right? Exactly. They know how the applications talk, et cetera. So we have to rely on tools. You don't know what you don't know. But the nice thing about this is as you go through that process of app rationalization and going through the process of monitoring your applications, you learn a whole lot more about your environment. The nice thing about that is that can actually be ported over to, say, disaster recovery runbooks and things like that. So it's actually, and some people think it's an exercise in futility, but to be fair, it actually nets a lot more rewards by doing it than it does not doing it. Because
it turns the tide significantly. The moment they run login site, they start to see the actual, all the insights.
Absolutely, absolutely. So where we see most customers from a greenfield perspective, sure. We can immediately start with that kind of whitelist zero trust model where we want to start everything out right away. In brownfield types of environments, a lot of customers start with one simple application. There's a specific use case that they want to accomplish. for things like healthcare. Like they want to, one of my customers wanted to do, secure like Care Fusion, which is like their application for, Schedule 1 drug monitoring, right, and so forth. So that's what they started with to start. And then what they did was they started building these more secure types of clusters where these applications already had these security postures in place. And then they slowly started migrating the other applications over to those environments. But you have to know how those other applications interact with everything else, otherwise it becomes kind of difficult to do that. That's where the tooling kind of comes in from that perspective. From ubiquity and centralized control, our ability to do the security policy, again, public cloud, on-premises, from one NSX manager, our ability to write those policies regardless of where they live.
So just to follow up on the public cloud, so we could apply these same principles to an AWS?
Absolutely, AWS or an Azure workload. So, and I'm going to show how we do it for an EMR application here in just a second, and I'll show kind of how that works.
Thank you.
Yep. Promise we're almost done here. So, from a slide perspective, didn't mean, I hate beating people up with slides. Normally I would have done this on the whiteboard. But from we see customers basically building their security policies based on one of these three kind of different aspects, right? So network-based policies are kind of more physical firewall, right? I need an IP address, those kinds of things. But policies are very network-centric, meaning that I need to know the IP addresses to write my policies. Infrastructure-based are very similar to like what Tom was saying, where infrastructure-centric types of things are, I'm using a logical construct, it's a logical switch, or it's this data center, or it's this cluster, or those types of things. And as we kind of move up the pyramid to the very top are where most of our customers kind of start with, and that's our ability to do micro-segmentation around a specific type of application where the data center environments are dynamic, the workloads move around. The nice thing about this is that as workloads move around, the firewalling policy, all the security policy moves with the application. So if our systems are working on one host and move to another, things like DRS are shuffling things around. Due to resource scheduling, it doesn't matter from NSX's perspective. The same security policy is enforced even on a vMotion. Okay. This is what we've seen from most of our most commonly deployed model for how we write our firewall rules, and breaking down the rule sets into specific types of groups. Right. So the top ones being around emergency rules. Those would be things for like quarantining. Or, I need to do a quick allow rule based on something I'm doing some work on. Quarantining being, I need to stop the bleeding now, right? I have a workload that is compromised, and I need to immediately start blocking traffic to it as much as possible. I can put a rule at the very top. The firewall works in a very similar fashion to any other firewall, top down, and go from there. Infrastructure-based rules for things like shared services, so AD, DNS, NTP. We all know that we're trying to secure applications from talking to themselves or other applications, but we always forget, or sometimes forget that these systems actually all still talk to all these shared kind of services, right? So they still need kind of these care and feeding for being able to do that. Environment rules based on things like our ability to provide security and say that these are development workloads and these are production workloads. So from a customer perspective, you could have prod and dev running on the same hosts. You can give them more priority through other things with vSphere for like resource groups and so forth. But you can also have the same security posture for your development environment and your production environment at the same time. So when your application developers test their code, they're actually testing against real production-based rules, and all they do is they move that code over to the production environment that has the same rule sets in place. Right, so our ability to make that easier for folks because as we tested it in test and it worked just fine, then we moved it to prod, and now all of a sudden we can't figure out why it doesn't work. Go ahead.
So I don't know if you're going to cover it in this at all, or if you can speak to it. But when you're wanting to provide protections or firewalling in a PKS, Docker, Kubernetes type instances and context.
Yeah. So. We handle that from a Kubernetes or a PKS perspective. There is a plugin called the NSX container plugin for Kubernetes and Cloud Foundry. Mm-hmm. Functionally, what that is that's a plugin that runs that translates things like network policy and it translates them to the NSX firewall to create firewall rules. I could show you. It's not fully fleshed out, but I can kind of show you what that looks like in the firewall. But basically, as you write your container-based workloads, you write a network policy for Kubernetes, right? And you apply that network policy for how those containers talk to each other. When you apply that through something like PKS, NCP intercepts that and translates those into NSX firewall rules. So we actually translate all the container-based network policy over to a firewall rule, which also means that I can now allow my VM workloads to talk to my containers through the NSX firewall the same way that we would do a VM to VM type of communication. Does that answer, Chris? Mm-hmm. Okay.
Thank you.
Just quickly, rules between our applications, right? So we know that our applications still talk to other applications. And then obviously our rules between our app tiers or our web tiers and so forth. And then lastly is a deny rule, depending upon if you're doing a whitelisting type of model. The nice thing about from NSX's perspective is, if you think about it, I put a firewall at every one of the VNICs, but my firewall is actually default allow. Does anyone know why? Does that make sense? Why you would be a default allow? Because if it's not default allow, you just denial of service to your entire infrastructure by doing it, right? By putting the firewalls in place. So it is default open to start so that you can onboard the applications quickly. The default rule here is set for deny. That's typically in a greenfield environment. The nice thing is you can write application-based blocks as you see fit further up in the firewall. So back kind of to the question about how you operationalize these things and how you actually get to this process. All we need to do is we need to prepare the host for NSX. We need to install the NSX bits. The last thing is we need to identify the applications and start monitoring the flows between the applications. So from our application perspective, we have ARM, or we have the application rule manager, which actually goes through and can take a look at the flows in real time and actually create recommendations for firewall rules. The next tool is around vRealize Network Insight. So vRealize Network Insight was the Arkin acquisition. So that has the ability to, it's kind of more robust in terms of being able to see the entire infrastructure. It does more than just security planning. It has a more holistic view, if you will, of the entire network infrastructure. It can see things down to the physical switch level, also into the virtual switch level and the firewalling capabilities of Palo Alto and Checkpoint's firewalls as well.
And flows.
And flows. Yeah, so the nice thing about this is that these two tools here provide you recommendations based on how the application actually functions for how to write your firewall rules. Okay?
Automated?
Huh?
Are the ARM rules automated? Like if it sees a
the ARM is actually automated. The VRNI provides you the recommendations, and then you go in and actually take a look at the rules. The nice thing is that these two systems will actually let you know whether or not there's actually a rule already in place. Right? So it gives you a recommendation, but it will actually show you the firewall rule that's coming from the NSX distributed firewall and tells you which rule is already being applied for that flow. If that's not the rule that you want, then you can move up, you can change the rule around or rewrite a new rule based on the flow, and then it will show that rule instead. Does that make sense?
So ARM has anomaly detection built in?
It does not have anomaly detection in terms of like if the application is behaving badly.
Somebody downloaded 3 gigs from a SQL database when
Sure.
they normally only get 200 megs a day.
Absolutely, right? So it doesn't do things like that
Okay.
from an anomaly detection perspective. What these tools do, and I don't want to say do again, but what they do is that they provide you the flows so that you can actually start taking them back to your application owners and saying, this is what I see your application actually doing. We need to start actually taking a look at those flows and determining whether or not those flows are the actual flows of the application or not. Once we have analyzed the application profile and understood the flows and rationalized all of the different, all the flow information, then we're going to write our security policy and put it in place. Pretty simple concept. The question that usually comes up is, how long do I monitor my applications? And my answer to that is it depends, the typical IT answer, right? Depends on the application. So understand the application. Don't monitor a payroll application that runs a batch job every 2 weeks and only monitor it for 2 days, right? It's mostly just common sense in terms of how long you need to monitor. The nice thing is that most of these tools can monitor the application for well over 30 days, well into 90 and 180, so forth. So from there.